There will be a group activity where you'll have a chance to look at several problems and examples in real life to come up with your own inequalities and equations. You will then display a graph to show the overlapping region, and you will come up with the optimization equation and answer the question that usually deals with either the maximization of profit or the minimization of cost. So there are several problems that we will look at, and you will be able to work with a partner and see how you can progress through these challenges. Once you're finished, you will also have access to a little bit of guidance, and I want to explain some of the problems right quick so that you know exactly what to do and what to pay attention to. So really, what's happening with linear programming is the following. You're going to need some inequalities, and you will have one equation. The equation that you will come up with is dealing with the optimization piece. So really, linear programming is looking at how to make the most money, or how to save the most money, really, by spending less. So here's what's happening. In this particular example, skateboards and inline skates are produced and sold. So now the question is, what is the best combination of sales? Okay, so you will have to decide what's going to be on your x-axis, what's going to be on your y-axis. In this case, it really doesn't matter. And then you will be shading a region, and you'll be looking for the overlap. Okay, so then once you have it all going, oftentimes you have to use solving systems by substitution to see where these points actually end up being. So let me show you right quick. As you can see, the region, just check it out. The region right here, okay, the enclosed region ends up being some sort of polygon. And you have vertices. These are the vertices I'm talking about. Okay, you will have to find out what the location of each vertex is, and then you're going to use your optimization, in this case maximization equation, to plug those values in for your x. In this case, it's s for me, and your y-axis represents L inline skates. So there you have it. And then you just plug in those values and see which one of the vertices, in this case you have 2, 4, 5 vertices, one of them will produce a maximum output. So that's what you're after, and then you answer the question. Be sure that you do answer the question. Again, on a different example, another example will be dealing with a bakery. Notice how I organize my notes to say, okay, on one side, I have one thing going on the other, whatever else they're talking about. In this case, they're talking about bread and muffins. So I kind of organize the information that can be quite overwhelming at first when you look at the project that offers it like this. Okay, so it's pretty wordy. You want to then isolate what it is you're interested in and kind of organize your thoughts. Then you're like, okay, what's my maximization equation? In this case, once again, largest profit. That's why I use the letter P right here. Now, let me tell you this. That's the only equation that you have when you're working with linear programming. That's your optimization stuff. Other than that, you really have inequalities. And based on the word problem, you'll set that up. Now, oftentimes there's a hidden agenda, so to speak. So right here, it doesn't tell you that in the text directly, but you have to make some muffins and you have to make some bread in order to even make sense of the problem. So that is something that you have to come up with sometimes. You know that you're not going to be in the negative numbers here or there. It doesn't make sense. So quadrant 1 is it. One important piece of information, maximization equation is not to be graphed. Okay, not graphed. This is what you use to then see what the largest profit or the lowest cost would be. So this is what the maximization equation is used for, not for graphing. All the other ones, which are inequalities, are graphed. Now in the answer sheets, I only shaded the region that is important for us, basically disregarding the stuff around it, just to kind of allow you to focus on the most important things. Now, when you test the vertices, make sure that you answer the question. In this case, the maximum profit happens when so much bread is made and so many muffins are baked, or batches thereof. So several problems you'll see, all of that connects to real life, beautifully displayed, and that's going to be your job. Please do that and organize your thoughts, talk to each other. I also made sure that when, the intersections are a little more shady and you're like, I don't know where exactly that point of intersection happens, let me go ahead and just figure it out on paper by substitution. You can do that. And you have to do that unless you are absolutely sure you're talking about the correct point. Now, one more thing to mention. What was it? So there are, again, see several examples. Oh yeah, when you are talking about percent, please remember you will not be using the number when it comes to investment. You're not going to be using the number in front of your percent sign as is. You have to divide it by 100 because percent means out of 100. So you're going to convert it into a decimal and work accordingly. Now, when I plotted my points, please notice nothing says 2,000, 4,000, 20,000. But the way I took care of it is by doing this so that it doesn't get too much for me to label. So I just said in thousands, okay? And then you go from there. When I plugged it in, however, I reverted back to the actual numbers, 7,000, 15,000, 14,000, whatever it is. And then you figure out when you make the most money. That, dear people, is actually one of those things that can really be applicable in real life if you want to make money. I wish you fun.